Good day, grade 10 physics learners. How are you guys doing today? It's your teacher, Mr. Marshall A.C. Candiado, bringing to you again another physics lesson. Today we will be looking at the concept momentum. Right, this is a new concept for you guys. It's a brand new concept for you guys, momentum. But before we look at momentum, let us just try and recall quickly what we looked at in lesson number, which is what? This is lesson number 3. So in lesson number 2. In lesson number 2, we looked at the concept of force and how to use mass when given mass and acceleration, how we can use those values to calculate force, and how in other cases we were given force and we had to find the acceleration or to find the mass. We also looked at the different types of forces that we encounter in everyday life. We talked about gravitational force. You guys gave me forces such as attraction, repulsion. You talked about electrostatic force. You talked about different forces when we then had the discussion, right? So I am happy that you guys understood that concept, and now we are moving on to the concept of momentum, right? Momentum. So what are our objectives for today's lesson? By the end of this lesson, let us look at the objectives. The objectives are always the ones that we have here. Objectives, these are the objectives. You always find them. I usually place them on that side of the board. So the objectives for today are saying, if we look, it says describe momentum as the product of mass and velocity. Describe momentum as the product of mass times velocity. Recall and use the formula for momentum, which is the one which says mass times velocity. Then also to recall the concept of impulse. Right, we'll also look at impulse in this lesson, and to be able to calculate impulse given certain values. Right. So in this lesson, I will mostly want us to focus on calculations. Right, I'll just go through the definition of momentum, the formula that you use, but mostly I want to focus on calculations so that you guys can have a clear example that you follow when you are carrying out your own calculations. Right, let's get into it. Okay, so now guys, you just pause the video just for a minute, so that you can look at the objectives and understand what they're saying. Right, welcome back guys. So we are talking and we are looking at the concept of momentum. So what is momentum? We're saying momentum is the product of the mass of an object multiplied by its velocity. That is the product, mass times velocity. So if you have an object moving, right? If you have a moving object, that object has momentum, right? That object has momentum. If an object is moving, therefore it has momentum because the object has mass, right? Because the object obviously has matter in it, therefore it has mass, right? And it is moving, therefore it has a certain velocity with which it is moving, right? So when we have that mass multiplied by the velocity, right, that's when we get momentum. Momentum is equals to mass multiplied by velocity. Our mass has to be in kilograms and our velocity has to be in meters per second. Our velocity has to be in meters per second. Okay, so when you are carrying out calculations and you are given, and we say an object, a 500-gram object was moving at 55 centimeters per second, you have to go back and you have to take those 500 grams and you have to convert them to kilograms. You have to take those centimeters per second and you have to convert them to meters per second, because those are the units that we use when calculating momentum. Otherwise you will get the wrong answer. Okay, so the symbol for momentum that we use is P, which is equals to mass. Symbol unit for mass is M, unit for velocity is V. P is equals to mv. P is equals to mv. That is your calculation for your formula for calculating momentum. We know what mass is. right? If you don't know what mass is, I put it in the document. If you don't know what velocity is, I put it in the document, but you can as well go and research for yourself. We are now in grade 10 physics. We know what mass is. We know what velocity is. We have been talking about velocity since the beginning of the year, right? So now, let us carry out, because like I said, what I really want us to do in this lesson is to be able to carry out calculations to find momentum. To say if we are given a body with a certain mass and we are told its velocity, then we should be able to calculate its momentum. So let me put a question on the board so that you guys can try and answer it, and then I'll assist you with that as well. Okay, so you guys can take down the question that is on the board, right, which says determine the momentum of a golf ball. Determine the momentum of a 100-gram golf ball traveling at 25 meters per second to the right. Why do we mention the aspect of moving to the right? Because momentum is a vector quantity. Momentum is a vector quantity. Direction is also given in momentum. So if we're moving to the right, that means that the momentum is actually positive. You will find that when we do calculations on change of momentum, if one object is moving to the right and we say it has positive momentum and its value is positive, if an object is moving from the left, that object is actually having negative momentum, and the value that you have of its momentum is going to be negative. So this is important to remember. Momentum is a vector quantity. Therefore, it has both magnitude and direction. It has both magnitude and direction. It has both of those. Okay, so your question is saying determine the momentum of a 100-gram golf ball moving at a speed or a velocity of 25 meters per second to the right. To the right. Okay, so you guys can do the calculation quickly, and I'll put the answer for you guys on the board, but carry it out for yourself first. So pause the video for about 2-3 minutes. 2 or 3 minutes. When I say 2-3 minutes, 2 or 3 minutes, right? So just pause the video and carry out the calculation. Right, so what do we have here now? I hope you were able to carry out your calculation. So P, momentum, is equals to mass times velocity. P is equals to mass times velocity. What is our mass? Our mass here is given as 100 grams. Our mass is given as 100 grams. But remember, our mass should be in kilograms. So our first task here is to convert the mass to kilograms, 100 grams to kilograms. So in 100 grams, we say we convert it to kilograms. People should know by this stage, we're in grade 10 physics, you should know how to convert 100 grams to kilograms. Yes, Prince, yeah, you guys should know by now how to convert 100 grams to kilograms. So 100 grams is equivalent to 0.1 kgs. Okay, and the velocity is given already in meters per second, so therefore there is no need to change the velocity. It's fine the way it is. So it says 0.1 kgs multiplied by 25 meters per second. And our answer that we get, I know you guys are going to be busy punching into your calculators, but effectively 0.1 times 25 is the same as saying 25 divided by 10, right? Just allow yourself to always do a bit of mental math. Your brain is capable of doing it, by the way. Your mind is capable. You just have to allow yourself to do it. Okay, so 0.1 multiplied by 25 is 2.5. 2.5 kilogram meters per second, right? So this is our unit for momentum. Kilogram meters per second. Kilogram meters per second. That is our unit for momentum. Okay, right. So we have this concept of momentum. Then we also have a situation where we can have to calculate change in momentum. Change in momentum, right? Change in momentum, if this is momentum, change in momentum will be written as delta P. From your mathematics, you know about dy dx, change in y, change in x, right? dy dx. You know that this is dp, right? Delta p, change in p. Change in p, delta p is equivalent to what, right? So change in p is found by also having the mass, right? If we're going to have change in momentum. Change in momentum only applies, remember that momentum is only applicable for moving bodies, right? And if the mass, we usually take the mass as being constant. So change in P would be equal to mass, right? This is the mass, multiplied by change in velocity. Because if momentum is changing, it means that most likely our velocity is changing. Because the object, just imagine this 100-gram golf ball, right? If the golfer hits it, right? Of course, it's going to start at a higher velocity, but it's going to slow down until it lands, and then it's going to come to rest. So its velocity changes, but its mass always remains 0.1 kgs. So when we're looking at change in momentum, okay. When we're looking at change in momentum, delta P, we say mass multiplied by change in velocity. Change in velocity is the same as saying change in velocity, delta V being final velocity minus initial velocity. Delta V here, the same as, remember that thing where you say V minus U? Final velocity minus initial velocity. Final velocity minus initial velocity. Right? That is the formula that you would use when we want to calculate change in momentum. Delta P. Right? Delta P is equals to mass multiplied by change in velocity multiplied by, just change in velocity. So let me put a question again on the board so we can just do that as well. Okay, so I have decided not to write on the board because the question is a bit too long and I don't want to write on the board. So I will read the question for you guys, and I'll read it and you guys will write it, right? You write it somewhere. The good thing is that when I read it, you can then play it again and again until you get it correctly. So a motorist traveling at, I'm reading from your living physics, grade 10 and 11, activity number 18, living physics, activity number 18, question number 2. The question says, a motorist traveling at 35 meters per second, approaches a stop sign and slows down before coming to a complete standstill. The car and its passengers have a combined mass of 500 kilograms, 500 kgs. Determine the car's change in momentum. A motorist traveling at 35 meters per second approaches a stop sign and slows down before coming to a complete standstill. The car and its passengers have a combined mass of 500 kgs. Determine the car's change in momentum, right? Hint, when a car stops, right, when a car comes to a complete standstill, its final velocity is 0, right? So calculate that one, please. Right, are you guys back? Cool. Right, so I hope you've done the calculation for that one, right? I've done it on the board for you just to confirm, and then we'll also just discuss again when we meet in the group, in the comments, right? So we were given a vehicle with a combined mass, the vehicle and its passengers have a combined mass of 500 kgs, right? We were given the velocity as having an initial velocity. The car was having an initial velocity of 35 meters per second, but then it comes to a complete standstill, which means that its final velocity is actually 0 meters per second, right? And we know that our calculation has to say to us final minus initial. So final velocity was then 0 meters per second, initial velocity was 35 meters per second. So when we do our calculation, we have to find change in V. And our change in V, delta V, this triangle means change. This triangle means change, delta V. Okay, so final velocity, right? Final velocity minus initial velocity. Let me remove this stuff. At this level, you must know, right? So final velocity minus initial velocity is basically u minus v. U, right? Minus v, or v minus u. V minus u. Final velocity minus initial velocity, v minus u, v minus u. 0 meters per second minus 35 meters per second, which gives you 0 minus 35 is equivalent to minus 35. So you multiply your mass times your velocity. Okay? Remember, don't worry that the velocity is negative. Don't worry about that part. Okay? 500 kgs multiplied by negative 35 gives you minus or negative 17,500 kilogram meters per second. Negative 17,500. So you're changing momentum because this car was moving with a positive momentum, but it has now come to a standstill. Okay, so its momentum is effectively reduced, right? So you now have it be minus 17,500 kilogram meters per second, because that is the formula for momentum, and that is the change in momentum for that particular vehicle, right? So that is that on momentum and change in momentum. Then we also want to look quickly at impulse, right? We also want to look at impulse. So now you can just have a look, read on what impulse is, then we'll just discuss it quickly. Okay, so guys, we wanted to look now at impulse. Impulse of force, right? Impulse, which is basically another way of saying change in momentum, but now looking at the time during which a force is applied, which then results in the change in momentum. Let me try to say that as simply as I possibly can. Right, so if we have an object that is moving, that object is moving with a certain momentum, like we have just seen, given its mass and given its velocity, we can tell what the momentum of that body is. Now, if we were to increase a force, right, to apply an additional force, either supporting the movement or opposing the movement, then the momentum of that body will change. The momentum of that body will change. And the momentum of that body would change also in proportion to the amount of time that force is applied. Okay? So just imagine if you were pushing a car, right? A car is having difficulties moving, it's having difficulty starting, and you come there and you want to push the car and you only push it for a second. And then the car doesn't move. And you think, oh, but I pushed with a lot of force, but it was only for 1 second. Okay? Right? That's me pushing the car. Like that, right? That's me pushing. I'm not pushing the screen. I'm pushing the car. So if you only push for a small time, you'll find that the change in momentum is also very minimal. So the change in momentum is directly proportional to the force that is applied, right? And also to the time taken during which the force is being applied. So we have this formula, change in momentum, delta P, is equal to the force that is being applied multiplied by the change in time, delta T, to say how many seconds did you take. Final time minus delta. Change in time, change in velocity, change in height is always going to be final height minus initial height, or is going to be final time minus initial time. So if the initial time was 0 seconds and the final time was 50 seconds, that means you have pushed for 50 seconds, right? This is the formula we are using, F delta T. We should be able just to recall this one because we are going to have to input it to then carry out our calculations when we want to find either force, the force that was applied, or time that was taken, or the change in momentum. So this F delta T is actually the impulse, and it's also calculated saying mass multiplied by final velocity minus initial velocity. Okay, when we have a longer discussion, I'll explain it more. Now, for time's sake, I'll just now put another question for you guys on the board. And you can calculate that question, and then you guys can give me the answer when we meet in our next physics lesson in the groups, right? So I will just put the question on the board for you, and then you guys can answer it. Okay. Right, so let's look at the question that's on the board. Okay, this is a word question. The other thing that I wanted to mention to you guys was how we should be able to read word questions and be able to derive which aspects of this word question are able to fit into the formulas that would have been given. Okay, so we know that our formula for change in momentum is delta P is equals to M delta V. Delta V, change in V, is V minus U, change in velocity, right? Which is also equal to F delta T, right? Force change in time, right? So if you are given this sort of calculation, says a 2,000 kilogram rocket, this is the mass of the rocket, right? So the mass you have been given accelerates from rest, you have your initial velocity, before reaching a speed of 45 meters per second, that is our final velocity in this question, 45 meters per second. The engines exert a force of 1,200 newtons, you have your F. So now you have your M, you have your delta V, you have your F. What you are looking for is the time, so change in time. So the change in time, just calculate the time, right? Just calculate the time. It is the time that you are looking for to say how long did it take, how much time did it take, how much time it took for the rocket to reach that particular speed. Okay, so you guys should be able to calculate that speed using, I've just put that formula there, right? But it will require you guys to, to really do some calculations, right? And this is not even the main homework. This is just one of those questions, just basically an example. But this is physics. Okay, this is physics. We chose to be here. Yeah, we were not forced to be here. We chose to be here. We said, yes, we're going to do physics. We're going to do chemistry. We're going to be scientists. That's what we're doing now. That's what we're doing now. So this basically brings us to the end of this lesson. You guys will do this calculation. I'm trying to look at the objectives that we had. We should be able now to describe momentum, right? Product of mass and velocity. Recall and use the formula for momentum. Also, we actually did more, didn't we? Because we also looked at what? At change in momentum. Change in momentum, delta P, right? Delta P, change in P, change in momentum. Then we've also looked now at impulse, what impulse is. And we say that impulse is basically now looking at a change in momentum and observing the force that causes that change in momentum. Right, so in the next lesson we will look at the law of conservation of momentum. The law of conservation of momentum. You guys will answer this question. You will also answer the questions that are on the PDF document. Right, thank you guys. As always, you have been great. Thank you for paying attention. I'll meet you in the next lesson, or for you guys, I'll meet you when we discuss this lesson. Okay, this is Marshall A.C. Candiado. Thank you guys. You're awesome.